I've done a couple of videos on True RMS in multimeters and clamp meters, and a question that I get asked a lot is True RMS for AC only or is it for DC? And True RMS is all about taking an AC signal and determining the heating value that it would be equivalent to a DC signal. So there isn't such a thing as a DC True RMS multimeter or clamp meter. But there are multimeters and clamp meters that can measure True RMS AC plus DC together. Now it's kind of rare to find that. I only have this multimeter that can do AC plus DC True RMS and this amp probe clamp meter that can do AC plus DC. There are a few other meters out there that can do it, but it is kind of rare to find, or really in your higher end meters. And what this will do is combine the AC and DC values together. The formula is the AC component squared plus the DC component squared, and the square root of that will give you your AC plus DC True RMS value. So what I've got set up here right now is a multimeter that's looking at this AC waveform, and this is set to measure AC, this is set to measure DC, and this is doing the AC plus DC measurement. So right now, with just a pure sine wave coming in and no DC component, you can see that at 3 volts peak to peak right now, I'm getting 1.05 volts RMS out of my AC and my AC plus DC. Going up to 4 volts peak to peak, I'm getting 1.41, which is should be the calculated value is 1.414. 6 volts peak to peak, I'm getting 2.119 out of both the AC and DC True RMS meters. So now I've got my AC set down to 2 millivolts, and you can see that I'm only getting 1 millivolt on the AC meter. But let me turn up the DC offset. So with 1 volt DC, you can see that my DC meter is showing 1 volts DC. My AC plus DC True RMS is showing 1 volt 0.996. Going up to 2 volts, I've got 2 volts on my DC meter, 2 volts on the AC plus DC True RMS meter. So now let's take a look what happens when I combine the AC signal and the DC offset together. So I'm back to having 4 volts peak to peak on my AC signal. You can see this is 1 volt per division, so I'm at 4 volts peak to peak. The RMS value is should be 1.414, and both of my meters right now are showing close to 1.414. So let me turn the DC offset up to 1 volt. You can see the AC signal rise by 1 volt DC. This meter is showing the 1 volt DC. I'm still getting 1.4 volts AC on this guy, even because I changed the DC offset, doesn't affect his reading of 1.414. But now the calculated value for AC plus DC offset together should be 1.73, and I'm getting 1.726, so pretty close to the calculated value. If I take my offset up to 2 volts DC, you can see that now I'm writing up 2 volts DC on the AC on top of it. I have 2 volts DC here. I'm still at 1.414 on my AC, and my AC plus DC, the calculated value should be 2.449. I'm at 2.446. Same thing if I go up to 3 volts DC. You see the 3 volts here. The AC is staying solid at 1.414, and my AC plus DC is now up to 3.31. So the AC plus DC True RMS meter combines your AC and DC signal together for you without switching back and forth, and that's what you get with an AC plus DC True RMS meter. So now let's take a look at another scenario. Right now I've got an AC signal coming into a bridge rectifier. I've got 12 volts AC coming into the AC side of a bridge rectifier. You can see my sine wave here at 12 volts, and both my True RMS meter and my AC plus DC meter are measuring the 12 volts on that bridge rectifier. So now I'm going to move this to the DC side of that rectifier. And now you can see my full wave rectified signal coming off of the DC rectifier. And this guy is measuring 11 volts AC plus DC, where I've got a 5 volt AC component on here and a 9 volt DC component. But this guy is doing the square of the AC and square of the DC, square root of the two, giving me 11 volts total AC plus DC. So now let's put on a small capacitor to smooth that out a little bit. Now I didn't put on a very large capacitor, I just put enough on just to give me a little bit of smoothing, and you can see that now my DC component value has gone to 13 volts DC. I got 1.5 volts AC, and my AC plus DC is giving me 13.67. So now let's put on a little bit larger capacitor that's going to really knock down that ripple. So with a very large filter capacitor on there now, you can see that I'm measuring 15.7 volts DC. My AC component is down to only 145 millivolts, very little ripple on there, and I'm getting 15.7 volts on my AC plus DC True RMS. So it shows you how this guy is really calculating the amount of total voltage that you're getting, or total energy, you can call it. It's not really power. But doing the calculations for you. Now with both of these meters, you can, if you have a True RMS meter, you can get both of these readings and calculate it yourself. This is showing me the 5.2 volts AC component. I can switch to DC on this and get the same 9.7 volts DC that I'm reading there. And I can look at the AC and DC component and calculate out that the AC plus DC True RMS is 11 volts. So, your meter is capable of getting you this information. An AC plus DC True RMS meter just shows it to you all on one screen. So I hope that clears up some of the questions that you have on AC plus DC True RMS. There really isn't a DC True RMS meter. It is combining the DC component and the AC True RMS together when you look at AC plus DC True RMS. Please subscribe for more tech tips and reviews. It really does help the channel.